At a depth of 6,200 feet, which is about 1,890 meters, the camera of an unmanned submersible recorded a swimming creature. It had no scales. Its bones were transparent. Its mouth could not close. Scientists identified the species. They noted in their report, "This is a cod. Not the cod, you know. This is what deep-sea creatures actually become below 6,000 feet, or roughly 1,829 meters. You are sitting about 1.1 miles, which is about 1.8 kilometers, above an invisible boundary. That boundary is at a depth of 6,000 feet, which is about 1,829 meters. Oceanographers call the area starting here the Bathypelagic Zone. Some call it the Midnight Zone. Both names describe the same reality. This is where everything changes, not because it is deep, but because three physical conditions at this boundary apply simultaneously, and there are absolutely no exceptions. First, light. Sunlight completely disappears from 3,300 feet, or roughly 1,006 meters. At 6,000 feet, which is about 1,829 meters, you have already been in absolute darkness for 2,700 feet, which is about 823 meters. Not a dim darkness. Not a darkness your eyes can adjust to. Absolute darkness. Not a single photon exists here. Second, pressure. At 6,000 feet, or roughly 1,829 meters, the pressure reaches 182 atmospheres. That is equivalent to the weight of 182 cars pressing down on every square inch, which is roughly 6.4 square centimeters of your body, simultaneously, continuously. Third, temperature. 35 to 37 degrees Fahrenheit, or about 2 to 3 degrees Celsius. Stable. It does not change with the seasons. It does not change with the days. It is just that. Cold. Forever. Below 6,000 feet, which is about 1,829 meters, the rules change. What most people believe is this: deep-sea creatures are distinct, bizarre species, completely unrelated to what lives near the surface. They are something else entirely, created from scratch for that specific environment. The data does not support this. Over 60% of the creatures discovered in the Bathypelagic Zone belong to the same genus as surface creatures, the same taxonomic group, the same branch on the evolutionary tree. The only difference is how their genes are expressed after millions of years under pressure. Most deep-sea lineages have ancestors that once lived in shallow waters. They did not evolve from scratch. They were transformed by pressure, by darkness, by time, from things that already existed above. This means that when you look at a creature at 6,000 feet, which is roughly 1,829 meters, you are not looking at an alien species. You are looking at a version of something familiar, after pressure, darkness, and 300 million years have done their work. What has actually been recorded is this. Take fish as an example. The class Actinopterygii, the ray-finned fishes, accounts for over 99% of all existing fish species. They live at every depth, from the surface down to 26,000 feet, which is about 7,925 meters. The exact same class, but below 6,000 feet, or roughly 1,829 meters, everything about their structure is rewritten. The first problem is scales. Surface fish have scales to protect their bodies, reflect light for camouflage, and reduce friction while moving. Below 3,000 feet, which is about 914 meters, scales begin to reduce. There is no light to reflect and no visual predators to escape from. By 6,000 feet, or about 1,829 meters, the vast majority of fish species no longer have scales, just bare skin, completely dark to absorb the bioluminescent light of other creatures, or completely transparent, achieving invisibility not by blending in, but by disappearing altogether. The second problem is the gas bladder. The swim bladder, An air sac located inside the fish's body helps them maintain buoyancy near the surface without needing to swim continuously. Below 6,000 feet, which is about 1,829 meters, the pressure of 182 atmospheres crushes any normally structured air bladder. Evolution solved this in two different ways. Some species replaced it with lipid-filled tissue, as fat is lighter than water and acts as a float that cannot be crushed. Others eliminated it entirely. The anglerfish does not have a swim bladder. It does not float. It either swims or sinks. And when it stops swimming, it simply sinks into the darkness and waits. The third problem is the jaw. The viperfish has a jaw longer than its own body. Its teeth are so large that its mouth cannot fully close. From the outside, this looks like an aggressive design. But this is not an offensive design. This is a solution to scarcity. Prey at 6,000 feet, or roughly 1,829 meters, is so rare that a single miss can be the difference between surviving and starving to death. The jaw maximizes the capture area in an environment with no light to actually aim at a target. The same class Actinopterygii, the same ancestors, completely different in every observable structure. Pressure does not create new species. It rewrites the old ones. After the mid-roll ad is over, let me continue with mollusks, the phylum Mollusca, and two cases that best show what happens when the exact same lineage is pulled to opposite sides of the 6,000 feet, which is about 1,829 meters, boundary. The first case is the Dumbo octopus, Grimpoteuthis. It lives at depths between 9,800 and 13,000 feet, which is about 2,987 to 3,962 meters, much deeper than the boundary we are talking about. But its ancestors lived in shallow waters. It is the same genus as the octopus you might see in photos. And then, pressure and darkness did what they always do. Surface octopuses spray ink when threatened. Grimpoteuthis does not have an ink sac. There is no light at 10,000 feet, or roughly 3,048 meters, so ink cannot hide anything in absolute darkness. Surface octopuses constantly change their skin color for camouflage, communication, and warning. Grimpoteuthis does not change color. There are no visual predators at that depth. That ability became wasted energy. Evolution simply removed it. Surface octopuses move using jet propulsion, shooting water out the back to push their bodies forward. It is fast, but it costs a lot of energy. Grimpoteuthis moves using two small fins on the sides of its head, looking like a cartoon character's ears, which is the reason for the name Dumbo. It is slow, but it saves maximum energy. The Dumbo octopus does not actively hunt. It drifts, and when prey gets close enough, it eats. The second case is the giant squid, Architeuthis dux. It was confirmed to exist a long time ago through washed-up carcasses and inside the stomachs of sperm whales. But the first footage of a live giant squid in the wild was only recorded in 2004 at a depth of 3,000 feet, which is about 914 meters, by Japanese researchers. Its eye has a diameter of 11 inches, which is about 28 centimeters. It is the largest in the existing animal kingdom, but it is not for seeing in the dark. The darkness at 3,000 feet, or roughly 914 meters, is absolute. There is nothing to look at in the normal sense. That size exists to detect bioluminescence, specifically the blue light emitted from the heads of sperm whales as they move through the dark waters. The giant squid does not look in order to hunt. It looks to know when it needs to hide. Its swimming speed is much slower than surface squids. Its estimated caloric intake is extremely low compared to its body size. Its metabolic rate is so slow that scientists have not yet been able to measure it accurately. This is the pattern. Surface octopus. Active, colorful, fast, and territorial. Dumbo octopus. Passive, colorless, slow, and solitary. Surface squid. Moves in schools, reacts quickly, and chases. Giant squid. Solitary, slow, and waits. The same phylum Mollusca, the same evolutionary lineage. Pressure and darkness have rewritten every behavior, every structure, and every survival strategy. The consequences of this are still being measured. In 1939, a specimen of a small fish species was collected and described for the first time. Scientists noted its unusual features and filed the report. They could not observe it alive. 65 years later, in 2004, the Monterey Bay Aquarium Research Institute recorded this species for the first time in its natural environment at a depth of 2,000 feet, which is about 610 meters. When the footage was reviewed, researchers confirmed what the 1,939 specimen had suggested but could not prove. The head of this fish is completely transparent. It is not an anomaly. It is not a disease. This is the standard structure of the species. Macropina microstoma, the barrel-eye fish. Looking through the transparent head, you can see the brain. You can see the upper internal organs. And you can see two green tubular structures. Those are its eyes. Those two eyes can rotate from a position pointing straight up to a position pointing straight forward. No other fish species has been recorded having this mechanism. In all the footage recorded when a remotely operated vehicle approached, the eyes of the barrel-eye were always in the straight-up position. No one knows exactly what it is looking at above its head. The current hypothesis is that it is looking for the silhouettes of its prey, like shrimp or small jellyfish, moving above it, outlined by faint bioluminescent light sources. This hypothesis has not been confirmed by direct observation of its hunting behavior. Its behavior when a remotely operated vehicle is not present has never been recorded. As of this recording, it remains unclassified. Current estimates suggest that over 200,000 species of living creatures exist below 6,000 feet, which is about 1,829 meters. Less than 10% of them have been directly observed in their natural environment. File under Bathypelagic Zone, being categorized. Next file. The anglerfish problem. Why its biology should not function.